So, welcome. Welcome to our webinar on medical applications in software and additive manufacturing, from design to production in the medical industry. I'd like to just make you aware that questions are available to be asked in the chat box. You'll see a chat box just there in the user interface, and we'll try to answer them either during the webinar via text or at the end. So today we have a esteemed and packed lineup. On the left there is myself. My name is Anthony Rosengren. I'm an applications engineer for Markforged, based in Australia. We also have Philip Kuttner. He's Oceania Sales and Director at Dassault Systems. We have Dr. Esfandiar Kohi, Multi-Product Team Leader, ANZ Central Innovation. We have Mile, Solution Consultant at Dassault. And we have Adam Taylor. He's going to talk about grant funding opportunities and his from government incentives. So I'd like to start the presentation with a little bit of context. And I guess it goes without saying that we live in a dynamic world. We're all used to that by now after the last couple of years. With rapidly changing preferences in consumer demand and need, volatile labour conditions with little succession planning for CNC machinists, and supply chain contractions caused by lack of supply chain resilience and global unforeseen events. So if we have a look at this supply chain topic, conventional supply chains have multiple stages to get parts from the point of origin to the point of need. Each step adds cost, lead time, and existential risk of that part getting delivered. The situation makes it nearly impossible to respond to the challenges we've outlined relating to manufacturing agility and changing market requirements. So the Suez Canal crisis is the latest in how supply chains can be disrupted. This is a key link for global trade. As you know, part of the way that this was solved was by this guy down in the bottom left-hand corner. He used his digger to help to free the ship. So this is a key link. The Suez Canal is a key link for global trade. Do you really want your company to depend on this guy in the future when your customers need your products? As you know, he obviously did a great job, but imagine the pressure on this guy. So if you think that you can simply move to air, then you need to consider events like this volcano eruption in Iceland in 2010. Because of the ash, flights to and from Europe and flights within the continent were cancelled, causing the largest disruption of air travel since World War II. The International Air Transport Association estimated that the airline industry lost 200 million for every day European airspace was closed. So that's just 200 million for the airline industry. Imagine the money lost due to critical parts not being delivered on time. So this leads to the question which this webinar is focused on. How can we implement a design to production workflow into the medical industry? Let's find out. I'd like to hand over to our next speaker. So I believe we have Philip as our next speaker.
Hi, Anthony.
Hi, how's it going?
Yeah, hi. I think I'll be just starting this presentation. I think there's some. I'll just do the introduction on Philip's behalf, and continue with some overall introduction of our company solutions. Yeah.
Sounds good.
All right, let me present my screen. Right. Are you able to see my screen?
Yep, perfect.
Okay, cool. Okay, good morning, good afternoon. My name is Mila. I'm the industry process consultant from Dassault System. So me and Philip, we're here and we'll be used the next 20 minutes to have a quick overview of our company, the latest technology and the solutions that we have and how those things can help you in the medical industry from design to production. So we will go through this, and probably if you have any questions, you can just leave in the chat box and me and Philip will be more than happy to help you out. Okay, so quickly, let's have a look of what our Dassault System does. So many of you might have heard this company before. So we started years ago with these are some bio of our company that we are a organization across 100 plus 133 countries with 188 sites, and we have many R&D centers around the globe. And also we have a huge group of partners that is focusing on technologies, on online services, on sales, on education and research, and etc. And of course, we have a huge group of customers in the world, covering 11 industries in 140 countries. So our company's belief is that the virtual world extend and improve the real world. And that's why we come up with the idea of digital twin, this idea in 2018, or digital mockup, or sometimes we just refer to it as digital twin from the 80s. And we started our PLM service, PLM product lifecycle management solutions in the late 90s. And since about 9 years ago, we started this 3D experience platform. Even nowadays, we are calling ourselves the company a 3D experience company. And now we are trying to incorporate this virtual twin experience of human last year into the platform as well. Okay, so our purpose here is that Dassault System wants to provide business and people with the 3D experience universe to imagine sustainable innovations capable of harmonizing products, nature, and life. And for today, we are talking about the medical industry. So we have one example here to demonstrate how we are trying to achieve this target, as we mentioned in the previous page. We have one example here. This is one of the motor knee from the prosthetic. This is one of the prosthetic company that's doing this. And there are many challenges that we can see from this medical industry, namely regulatory compliance, time to market, reliability, cost reduction, product innovation, all those. And we have this roadmap that we can introduce to you that how our solution can help you guys to overcome those challenges. So you can see many points, but in general, I would say that it covers these few topics from design to governance in terms of management of the data of the project, in terms of simulation, and in terms of collaboration. And the way we call it is design, simulation, governance, and of course, the last part will be manufacturing. So for my next 15 minutes, the presentation, I'm gonna focusing more on the design, governance, simulation portion, and a little bit on the manufacturing, because I think after finish the design and the simulation, it's better that I can pass it back to Anthony, who will show you some of the great stuff of how you can do this production with their solutions. Okay, so without further ado, let me straightway start this demonstration. So when we're talking about the solutions nowadays, the thing we would like to highlight is about cloud solution. And as just now we mentioned about 3D experience, this is a cloud platform where everybody is able to join, to articulate their idea, to collaborate, to share things like a drawing, image, videos, CAD drawings, simulations, everything is managed within this centralized location. So you will see a centralized product management for products, for data, for projects, for process, for workflow, for everything. If you ask me what is the main difference or what is the meaning of going to the cloud, I would say The two main reasons. One is scalability. It means that the cloud is fully scalable. It can be customized, can be fit to your own organization, your own workflow, no matter the size of the organization. And the second thing is its powerfulness. I'll say the platform is way more powerful than the conventional on-premise solutions because you're no longer limited by the hardwares. So these are the two things we'll cover later through our presentation. Well, the first thing first, when you move to the cloud, I would say the first thing you'll notice that this is no longer the way how you manage your data, how you manage your files. We used to call them files or folders, but if it's in the platform, they'll notice that especially when you're moving or evolving with new products, like every day with all the challenges that you face in your industry, you'll see that it's really hard to manage certain data. But with the platform, the first thing you'll notice is that there'll be a life cycle and then making the management much easier. You can set the different stages of your product's life cycle, like private, in work, frozen, release, obsolete, and etc. And so you're no longer worried about losing the data, finding the wrong version, or you're always working on the latest version. So this is one of the benefits and one of the first things you'll notice when you come to a platform on the cloud. Right. So that's part of the governance, but I want to take one step back to the base. So we always talk about design to production. So now let's look at the product design. And come to the design stage. Many of you might have been working with some of our CAD design softwares like SolidWorks before or other CAD softwares. So you know here, the message we want to convey is that no matter what you are doing with your on-premise solutions or locally you're working with the solutions, you are able to achieve the same thing on the cloud. I would rather say better on the cloud. So let's say, for example, you're working on some part designs for this prosthetic products. You are able to do all the feature adding, you're all able to do the drawings, creations, all the detailings, everything. In fact, on the screen, they are seeing this is the version of SolidWorks cloud version, not really the on-premise version. But basically, they're the same, some minor differences. So what you are doing here, everything will be saved into the cloud. So everybody will be able to capture what you're talking about. And of course, it comes with a workflow naturally. Not only for the part level, you know, for a mature production, you also have to get all the precise definition of the model, which in that sense, we have to have some drawings, exploded views, or most importantly, is the bill of materials for a complex assembly like this, what you're showing on the screen. So this information is really important because after the design stage, you have to pass the information to the next party, like production, procurement, in-house manufacturing, or whoever is involved in this business. So you see on the screen, we are putting this thing onto the cloud, and everybody in the platform or who have access to the cloud will be able to see all this information. And furthermore, if you want to link up with your other systems like ERP system, this is also the place where you can get started. So that's for the design portion. And now let's talk a little bit more on the simulation side. So simulation, we know the idea is to validate your design, is to prove that your ideas are working before you make the actual products. So very simply, we can use the platform or use the solutions to create a simple stress static analysis. So for the part levels, you're able to assign materials, boundary conditions, loading cases, where you can see the stress and the displacement or even safety factor. And not only keeping it to yourself, but you can pass it on to the platform. So everybody in the organization or even outside of the organization is able to view the results. And not only on the part levels, but we are also able to do on the assembly levels. So for example, for many medical devices that is working with human body or onto human body, like this model is trying to replace, I mean, it's like a prosthetic leg. So that it might go through various conditions, vibrations, shocks. So we are able to create certain analysis like a frequency study, dynamic study to find out what is the natural frequency, what is the vibration mode. Are we able to sustain a certain force when this person is going through some extensive exercises like jogging, like jumping, or some other type of sports? So we can see the results, that what is the reaction forces, what is the stress, what is the safety factor. So we know that this component or this product is able to sustain. So that's for the cloud simulation. And this is the stage where I would like to take a little bit step further to talk about the whole simulation portfolio, where you can find them beneficial in your medical device and other like a life science related design and validation process. So just now in the video, what you saw, it's all about the online cloud solutions like the linear static analysis that is for structural designers. That's how we group our roles to cover different features or different capabilities. And we also have structural performance engineer if you want to do some nonlinear analysis. And in the video, just now you see the perspective, we want to simulate how this product behaves under such a intensive loading that can be done with structural mechanics engineer, or even durability if you want to study the fatigue behaviors. So besides the online or besides the cloud track, we have another track for the simulation products, which is the on-premise conventional simulations, namely like CST, Abacus, Xflow, and etc. But many names, but come to the general point is that they all cover these 8 disciplines: structure, multi-bodies, fluid, automations. So for structure, we have Abacus. For fluid, we have Xflow, Power Flow, automations, we have eyesight, etc. like that. So let me share a little bit more on the other side of the applications from the on-premise solutions. Since today we're talking about medical industry, and I have prepared a few slides just to share some of the use cases, some of the success stories from our customers, how they can use our solutions to address those challenges. So if you take a closer look at some of the fluid flow applications in the medical industry or in the pharma industry, you'll find quite a varying range of fidelity, with some of them being pure fluid flow, and some of them require multiple physics that needs to be modeled. So for the next few pages, you'll see how we address these scenarios. One of the first examples I'd like to highlight is this syringe ejection. And then that's pretty a good example, because some people might find this simulation really challenging with the other mesh-based solvers because of the nature of the geometry. We know the needle has a really large aspect ratio. It's very thin and very long. So it comes with a large number of cells if you want to have a reliable model. But that also causes a problem, is the stability problem. So the best way to handle such scenario would be the lattice Boltzmann CFD solver, or we call it the LBM approach. So that's why Xflow will be really a good choice in such kind of applications. So another example is like a mixer that you want to, for example, mix certain materials or like drugs, or during the research stage that you have to do some testing. We know that for this kind of a mixer simulation, the actual rotation of the stirrer at the bottom, or we call it the agitator, can be modeled using our LBM tools again, also, which is a really good example here. So LBM again stands for lattice Boltzmann solver. Another famous example, I believe many of you might have seen this in the news, which is the Leishan Hospital in China. So early last year, at the beginning of the outbreak of this pandemic in the city of Wuhan, China, the hospital are not enough to accommodate so many patients in short terms. So the Chinese government decided to build a new hospital dedicated for this pandemic. They call it Leishan Hospital. So it was requested to finish the project within 12 days. I mean, the whole production, everything. And Dassault System worked with our client in designing of the hospital using our lattice Boltzmann solution, which is the LBM approach. And the goal here, the goal here was to perform the pollution dispersion simulation and generate the analysis report to adjust the HVAC system if there was any issue. So that's one of the good examples that we can share with you. So far you have seen these examples are all for, we call it a pure fluid flow. Well, another application that you find it really, really useful, especially in medical industry, is FSI, or call it a fluid structure interaction. So I give you one example, is this aortic valve. Because we know many devices or your products, I believe, you have to deal with moving parts alongside with the fluid. But normal CFD solutions, most of the time, if they don't really have SSI capability, the mesh for solid will be treated always as stationary. So you won't see moving parts with the flow. But for medical industry, we know like this aortic valve or many other applications or devices, it has to move along or try to drive the fluid. So that's why FSI is really, really important in medical industry. So you can see that we can do structural deformation together with flow feature. In fact, on the left, you're seeing this. This is modeled by Abacus FEA, but on the right, you're seeing this fluid flow. It's done by our solution called X-Flow. So another example, quick example, is the peristaltic pump. So with the peristaltic pump, we are able to do the same thing. Below is the image of the structure of this pump, and the structural simulation are done by Abacus FEA, while the CFD side is handled by our LBM solutions. So you can see this is for the structural side. You can see how the peristaltic pump works. And you can see all the stress distribution, stress concentrations. And the next page, you can see the CFD results of how the fluid move inside this, this pipe here. Okay, so far we are only talking about CFDs. And another aspect of the applications can come from electromagnetic field, which is also one of the hot topic today. So I just give you a really simple example. Here we have some case studies about human exposures to EM field, electromagnetic fields. We know that for these standard communication bands, electromagnetic fields penetrates a certain millimeter to centimeter into the human body. So for compliance, the power loss density over a certain tissue mass is integrated. And that's why we need to have this SAR value. SAR stands for specific absorption rate. So we have to be compliant in compliance with this SAR regulation for those like frequency range below 6 gigahertz. With our CST solution, we were able to do this simulation and see how the SAR distribution is. So based on this result, you'll be able to see whether your design it's in compliance with this regulation. And of course, this is really great for designers for antenna design and positioning. I would say that this can provide you some great feedback and can guide you a lot. Okay, so I've been talking a little bit more on the simulation because that's one of the hot topic nowadays. And now I want to pull back my presentation to the overall cloud solution again. That's where we can finish the whole story. So the last 2 pages I want to talk about is about the centralized platform again. And just now we are talking about the design, the simulation, and there's one topic is called governance, or how you manage everything. We have seen how you control the revisions, how you control the life cycles of your data. Now we have another aspect that we want to talk about is the project management. So no matter what kind of project you are dealing with, you are able to assign tasks, you are able to monitor the resources, the labor work, and utilize or fully utilize whatever resources you have. And of course, the last part of this governance, the topic I want to talk about is communication. I think that should be something at the beginning, but just to make this presentation more smooth, I plan to show this as the last part, because when I'm done with the design, assuming I'm the designer, I'm done with all the design and simulation, I'm ready to pass this on to the next stage, which is for Anthony for the productions. So I have done design, these are the machining parts which are done, but there's this 3D printing parts that's for the full cover, and how it looks like. This is the way how it looks like in the 3D printing software, in which later on Anthony will be talking more on that. Well, I can pass this, of course, use the conventional ways by emails, but with the new technology, with the new solutions, I think it will be better if we can communicate in a centralized place, like in our community, in the cloud, on the cloud. So you can see the interface here. We have an interface here. We have everybody able to join this community, can view this thing on this view window, and you can also browse through the data repositories. And also I can create a post and just tag Anthony and say, hey, this is the cover you're looking for. I exported in STL, and the way to download to find it, it's through this 3D drive. No matter whether you're an internal colleague or your external partners or whoever, as long as you have access to this link, you're able to share data with me or vice versa. So that's the whole solutions that I would like to share with you, how the solutions can benefit you from design to production in this medical industry. And just a quick wrap up of the talks that we've gone through. We talk about the innovations, all because of it's all lies on the collaborations, and also we talk about the design to manufacturing through simulations and all the solutions that we have. So that's all I have, and I think that's all. Now I'll just continue the story. I'll just pass it back to Anthony. Thank you.
Thank you so much, Mila. So I will share my screen to move from design to actually manufacturing with high strength additive manufacturing. Okay. All right, so moving on to the next stage of the process, what I'm going to go through is some medical applications and our focus applications for with Markforged. Then I'm going to move into a deep dive into the role of Markforged into the medical industry using case studies. I'll move on to an application guide, and then a bit of an introduction to Markforged before we hand off to Adam. So let's have a quick look at the role of Markforged in medical applications. All right, so our focus on the left there is in surgical tooling, specifically functional prototypes and end-use parts, hospital equipment, so manufacturing aids, internal components and functional prototypes, PPE, and that's a big one for end-use parts, prosthetics and orthotics, which can be end-use parts, manufacturing aids and internal components, and medical physics, so radio transparent components and testing. What we don't focus on are surgical implants, biofabrication, surgical pre-planning, dentistry, and surgical guides. So with that in mind, let's have a look at a few case studies. A couple of slides ago, I mentioned PPE. So let's talk about that. After being awarded federal funding from the US government as part of the COVID-19 stimulus package, the state of Michigan in the US used part of this funding to place additive technology at small and medium-sized manufacturers concentrated in 2 counties that have more than 40,000 manufacturers combined. So what this initiative aimed at was at developing distributed digital manufacturing networks that enable more agile supply chains. It has the ability to immediately benefit local manufacturing economies by upskilling the workforce and diversifying the types of technology and services businesses can employ. So, but what the key part of this initiative is that while these small manufacturers are using these printers for their own purposes, when a crisis comes, all of these printers can then be used to create PPE. So it's going to be interesting. I'd like to invite the audience to just type in the chat box. My question is, how many of you experienced a lack of PPE last year? So if you experienced a lack of PPE, please let us know in the chat box. I'd like to get a rough feel for that experience. So with Project Diamond, what it enabled was on-demand manufacturing. So you're able to print any geometry, any time, any quantity. So rather than having that complex supply chain, you're able to produce these parts straight away. Our next case study is a collaboration between one of our partners, Delphic, and a hospital in Singapore. Help was urgently requested by the hospital for an incubator box and the components, and our partner helped out. You can see the quote by Ding Tan, the managing director of Delphic, that you can see the frustration that they're sick of being at the mercy of this damn virus. What was required were heat resistant parts that were flexible and strong. And what was made was the incubator box that protects healthcare professionals in the treatment of COVID-19 patients. The box is now proudly supplied to local hospitals with a supply of 800 per month. The incubator box is collapsible and resistant to heat sanitizing, which is a requirement from the hospitals. Moving on to a metal case study in surgical prototypes. And the challenge in this case for Shakla Medical was that they initially prototyped using CNC machining, but found that long lead times were presenting major slowdowns in iterating on prototypes and preventing them from quickly getting their product to market. Shakla Medical has significantly reduced their product commercialization time by leveraging carbon fiber 3D printer and the Metalex system. Engineers at Shakla are now able to use this rather than having to wait a long time to get these parts CNC machined. Moving on. So this company here is called Khoa, and they are based in Europe, and their mission is to achieve orthopedic outcomes through advanced technologies. The interesting thing about this company is they've chosen, rather than focusing on additive manufacturing for end-use parts, they've focused, their pain point, I guess, was their fixturing systems and CMM. So that's how they use high-strength additive manufacturing, and that's what's given the most value to their business. Moving back to Australia, what this company here is, or I guess it's an institution, is the Australian Institute of Sport. And their challenge, or one of their challenges, was to create a custom release aid with geometry and maths that would otherwise be impossible to create through machining processes. And the result was a custom release aid that was co-designed by the coach and this athlete, as well as engineers at the Australian Institute of Sport, to produce a part with optimum weight, shape, and hardness. So you can see here the part in use on the left here, and you can see the geometry of that part would be very difficult to create with CNC machining, as well as the internal geometry and lightweighting that's involved, as there are air gaps inside that which enable the lightweight of that particular part. Staying with the Australian Institute of Sport, this particular project involved custom one-off knee pads for a wheelchair. The Australian Institute of Sport needed these knee pads to endure Olympic-level stress over a prolonged period of time and keep them as lightweight as possible for performance, maneuverability, and comfort. Moving on to another company called Toughwear Prosthetics, who produce end-use parts and functional prototypes. Toughwear Prosthetics are a Colorado-based company that specialize in making robust, affordable prosthetics. And this quote here from Bradley Vouch, the president and CEO of Toughwear, is interesting in terms of considering the supply chain question. The quote is, "I wasn't interested in losing 6 weeks of schedule while things were made in a machine shop," he says. "I'm actually able to get a lot more done in a much more concentrated time frame. I can produce an engineering design, print, and then begin running tests, sometimes in the same day. I can print what I need when I need it and continue with my iterative design process." So just to highlight the time that this company is saving, this is the traditional workflow. So if you compare all these steps of taking an impression, pouring liquid plaster into a mold, modifying the plaster, vacuum forming, and hand trimming, if you compare that to designing digitally and then 3D printing, you can see how they are able to save so much time. Moving on to a different application of an end-use part. So, basically, this part is a PCB enclosure for a neutral simulator device by Neuronica, based in Milan in Italy. This part is made through one of our materials, onyx fire retardant. So it's very important in terms of the material properties that this has fire retardant additive for safety purposes. Moving to Japan, this company is called Uchida, and they carry out research, development, design, and production of composite products. They use mark forged printers to respond to custom needs, deal with difficult geometry, increase mold strength, shorten development and lead time, and for small volume production. And back to Australia. This one is a particularly interesting, I guess, case study. What this company does is that they make portable X-ray machines. What COVID did is it increased demand of these machines massively because they help with the treatment of COVID. MicroX had the problem where they simply couldn't make the machines fast enough. And a lot of the reason why they couldn't make these machines fast enough is because the internal components were quite complex and they needed to be shipped from overseas. So what high strength additive manufacturing enabled was them to print these parts on demand, enabling them to get this product out the door in a crisis. And getting to the end of our case studies, one of our key applications is in medical physics, and this is an ionization chamber, which includes gas field radiation detectors. And this is widely used for the detection and measurement of certain types of ionizing radiation, X-rays, gamma rays, and beta particles. Another application of, I guess, onyx, which is radio transparent, is in this CSI board. And the key here is in this property of our flagship material, onyx, which is radio transparent. And it enables immobilization and support, enhancing the quality of radiation therapy. So as you consider your applications, we encourage you to engage with an applications engineer which can guide you through what the sort of best way of fulfilling your application is. So if we take the top row as an example, let's say your end product was in surgical tools and guides. The application for this particular product the best application would be in prototyping. And it's also important to compare how you would traditionally make this versus how you would make this through additive manufacturing and what the benefits are going to be. So I guess within Shakla Medical, the conventional way was to outsource or CNC machine the part, whereas with Mark Forged, it can be printed on demand. With this particular application, it's important to understand, and just like any application, it's also important to understand other factors like size, volume, strength, hardness, and other material properties. So with that in mind, who are Mark Forged? And basically, Mark Forged is an OEM of 3D printers, material, and software. And we have the world's largest fleet of industrial 3D printers with over 12,000 printers in the field in 73 countries, producing over 10 million parts. So a little bit about Mark Forged. We have, I guess on the right there, you see some of our strategic investors, which are of a variety of industries, including Microsoft, Siemens, Porsche, and Summit. And all of these companies have a need for additive manufacturing in the background. In 2018 and 2019, we won an award for second fastest growing hardware company. 2018, Forbes reported us as the next $1 billion startup. So we've got a few runs there on the board and continuing to grow at a very rapid rate. So to give a little bit of clarity, about what we actually produce. On the left there, you can see we produce continuous fiber reinforcement 3D printing. So these are high strength composite parts. We also produce and enable accessible metal 3D printing, along with automated printing with cloud software. And I'll talk a little bit more about this in further slides. So together we have the digital forge. So the digital forge combines our industrial materials, enterprise software, and industrial 3D printers. So here's a little bit of a snapshot of what our actual printers look like. So we have the industrial X7 there on the left and the metal system there on the right. And then moving to our materials. So we have a variety of materials for particular applications. Onyx is our, I guess, our flagship material. And then in addition to that, we have continuous fibers, which add various strength and stiffness properties to the Onyx, as well as materials like Onyx FR, fire retardant, nylon white, electrostatic discharge. In terms of metal, we have 17-4 stainless steel, Inconel, H13 tool steel, D2 tool steel, A2 tool steel, and copper. So as a bit of an example of our software, which is cloud-based, here's an example of what the interface looks like. So there you can see the internal view with the continuous fiber in that particular part for a composite part. You can move through the layers, have a look at the 3D version, and once you're happy with it, you can move to the to basically print and add more parts to that build platform. So in order to, we're constantly progressing with our software, and I'd like to present a little bit of a, a bit of a teaser for our, I guess, our latest addition to our software suite. So basically what we have here is our next generation software called Blacksmith, which is AI powered. It's centered around adaptive manufacturing so that you can get the right part every time and really increase the accuracy of your parts. I'm going to present a short video here. Okay, so what Blacksmith enables is in-process laser micrometer scanning so that you can end up with a much more accurate part, and you can have confidence that you have the right part every time. And I guess one of the ways that this is enabled is through in-process comparison. So as the printer is printing, it generates a point cloud of the external surfaces and some of the internal surfaces of the part that you're printing, so that the AI machine can work in the background to then enable you to print this same part with excellent accuracy, enabling you to have extremely good surface finish and tolerance for your parts. So basically, this is the digital forge. It is hardware that is built for today and designed for tomorrow, that's constantly able to be iterated, as time goes by. Okay, so that's it from my presentation. I believe we have Esfan. I think we have some time for Dr. Esfan, yeah? And then Adam Taylor, who's going to talk about some government incentives.
Yeah, thank you so much, Anthony. All right, let me share my screen and just getting the confirmation if you able to see my PowerPoint presentation.
Yeah.
Good, excellent. Thank you so much. Pretty quick, we are from Central Innovation, and over the last 27 years, we have helping our customer to transform their design and engineering and manufacturing process. And well, basically we're providing a variety of different services on the software side. Pretty well-known brands across the let's say globe are what we are presenting as a part of our software portfolio. SolidWorks, the new 3D experience, Simuli, Abacus technology, SMAP, XFlow, SVoot, DriveWorks. These are on the manufacturing sector. We have the architectural sector as well, with Archicad and Solbury and other brands. And obviously, we are doing our own hardware support, which is our IC 3D products. And this is the fastest liquid cooling desktop let's say solution we're providing for supporting any of this application. We have been developing a variety of different systems for our customers, which has become like part of their, let's say, usual service, such as hundreds of different macros in Sharp Task, or the very professional ERP, MRP connection from your PDM or data management solution with the data suite. And obviously, our organization is one of the registered RTO, let's say, training center, which we have a very huge list of registered trained people with the solution to be, let's say, in front of any let's say, business for hiring purpose. Now, they are serving wide array of industries, including the medical sector, automotive, aerospace, industrial equipment, which we got more than 8,000 customers across ANZ right now. And to be just, let's say, kind of specific on the medical sector, most of the, let's say, very well-known brand in a variety of verticals, such as Ostofix, Macrox, Medifab, Modsel, Invitec are our current customers across ANZ. What we do offer here is the first level of the communication with every single, let's say, participant in your business, either on the mechanical engineer or electrical engineer on R&D time, R&D team members, analysts, manufacturing firm, let's say engineers, machinists, or even going to other department as a part of the enterprise solution we have for documentation or for quality control or for marketing sales. So on the first level, we basically have the possibility and have a solution to talk to individual departments of your enterprise. But what is basically we are providing as a part of the enterprise solution here is the collaborating and management, let's say, between all these people and all the solution we have. Well, basically the design team and your control over the data, and obviously the, let's say, manufacturing and production connection is what we are basically going to have a fully synchronized workflow there. So individual solution plus the ERP connection plus the enterprise, let's say, solution as a part of Engineering 4.0. For that reason, we're providing a variety of services. It could include the training. It is, let's say, 12 hours a day support. It's implementation services. It's customization, specifically when we're talking about ERP and MRP connections, which is going to be a very specific requirement. A couple of very nice projects we've done across ANZ over the last couple of years. And obviously, we're providing consultation in every single, let's say, pathways that you can see here, either on the design side, analysis side, ERP connection, documentation, and etc. So with that one, we are pretty happy that this year, as Melee was, let's say, introducing, we have a variety of different simulation tools to enable any company to solve any sort of problem, including aeronautics, including the, let's say, medical application, including renewable energies, and etc. So to be specific, and at the end, what I have to say is a variety of, let's say, solution range in multi-domain, in multi-physics, starting from the SolidWorks solution, going to the Abacus solution, going to the, let's say, advanced fatigue solution, going to, let's say, non-parametric optimization or geometry optimization, and pretty advanced flow field. We have the solution here and support and training. So with that one, if you have any sort of inquiry, please get in touch with us, and we are more than happy to be more specific on what we are basically can provide for you. Thank you so much, Anthony.
My pleasure. Thank you so much, Esfan. So now I believe we have Adam Taylor on the line with us. Adam, I'd like to invite you to speak.
Thanks, Anthony. Just share my screen. Just want to confirm you guys can see that?
Yep.
Brilliant. Okay, so firstly, thank you very much for inviting EY here today. My name's Adam Taylor. I'm from our government incentives team, and today I want to talk to you about opportunities which are available in the government funding landscape in Australia, which relate to the medical industry. So we're looking at ways you can align projects in your pipeline with different sources of funding. And while there are thousands of funding opportunities out there and billions of dollars worth of funding today, I really just want to focus on one area, and that is the Modern Manufacturing Initiative. So this is $1.3 billion across 6 national manufacturing priorities, one of which is the medical industry. And the funding is split across 3 different streams. So the first is collaboration, which is aimed at providing capital for very large research projects to support business to business and business to research collaborations. The second is translation. This is aimed at commercializing an investment in non-R&D innovations. And the third is integration, and this is aimed at assisting manufacturers to integrate into local and international markets and supply chains. So for each of the national manufacturing priorities, when funding is opened, a thing called a priority roadmap is released, which identifies more clearly the vision and specific growth areas being targeted under each category. So the first round for translation and integration funding for the medical space has closed, but what that means is that the roadmap has been released and can give better insight for when you're looking to apply for the next round of this funding, which is set to be open in Q1 or Q2 of FY22. So within this roadmap, specifically, there are 5 key areas which have been highlighted for targeted growth that I wanted to share with you. So they are smart monitoring devices, high value add medicine, cutting edge treatments, think regenerative medicine, digital technology and platforms, and animal health. It is worth noting here that grants open and close quite quickly, with the first round opening and closing within a 1-month window for application. So leveraging this priority roadmap will increase your chances of having success when you go to lodge these applications. So on that note, the 2 key streams worth being aware for your project pipeline is firstly the translation stream. They're looking to back manufacturing businesses in strategic projects which will increase commercialization, embrace technology, innovation, and automation. They're looking to fund areas that are trying to grow production and bring commercial outcomes to new or existing markets. The integration stream is looking to invest in projects that will increase manufacturing businesses' participation in new, local, and global value chains, again, embracing this concept of technology, innovation, and automation. It is worth noting, applications for these grants will be competitive, and your projects will be assessed based on 3 merit criteria. These are 1, the alignment of your project to the program, to the objectives, which a sample of which are shown on the screen. 2, the capacity, capability, and resources to deliver the project. And 3, the impact of the grant funding on your project. On that topic, the funding structure for this system is at 50% co-funded, and they're looking to offer between $1 and $20 million for projects. So just to reiterate, the minimum project expenditure they're looking at is $2 million. But what are the eligible costs that you can include in this? It's really your usual suspects. So you're looking at things like plant and equipment, covering the design, acquisition, installation of plant or equipment. It can also include software, where the software is needed to facilitate the project that you're undertaking. We can cover labor costs, such as direct labor costs for employees, technical project management, but not administrative project management. And you can also cover things like contract expenditure, where you're getting third parties involved. You can also cover prototypes, where you're covering the construction of a prototype to prove that you have a commercially viable or unique product, as well as the IP patenting process and acquisitions. In addition to that, there's sort of another category which covers travel, domestic or overseas, building modifications, staff training, things of that nature. If the streams in the MMI don't really align with your projects, or perhaps the spend is a little bit outside of your range, there are some other opportunities that can be explored that are currently open. A few of these are on the screen. So the first is the Advanced Manufacturing Growth Center. They recently opened their commercialization fund, and in this, they're looking to support later stage commercialization in areas like pharmaceuticals and medical technologies. They're looking to fund between $100K and $1 million, 50% co-funding. And the closing date for that is actually June next year. So there's plenty of time to apply for it. If you're not quite towards the later commercialization stage, consider what's called the Rapid Applied Research Translation Initiative. So this is funding, I guess, the earlier side of it, and it's encouraging collaborations between academics and health service providers. And because it's catered more towards, I guess, more of that academic flair, they're looking at 250K to up to 10 million worth of funding. And given the academic side of things, they're looking at 100% funding for this. If none of those really fit, there are a suite of state-based job creation programs that you can consider applying for if you're looking to expand. Or if none of these are appealing, consider leveraging a non-grant source of funding via your R&D tax incentive, which can provide a tax offset for the work that you're doing. Please be aware though, this is just a snapshot of the funding opportunities that are currently open, and the landscape changes frequently. But aligning your projects and funding sources to the project objectives is an important part of increasing the likelihood of success for any grant application. The funding opportunities we've listed are Australian-based only. If you're joining this webinar and you're not based in Australia, but you would still like to discuss potential funding, please reach out to me on the contact details listed on the screen. I can reach out and leverage EY's global network, and I can put you in contact with someone in your local area. If you have a project which you think might align to any of the funding opportunities, or you'd just like to discuss a project further, please reach out to me. We're happy to assist in scoping projects, preparing applications, any of the above. Thank you very much for your time.
Thank you so much, Adam. So I'll just quickly share my screen. Okay, so firstly, I'd like to thank all of our presenters today, Mile, Esfandia, and Adam for contributing. It's been great to have, I guess, you know, like a sort of an approach from a software perspective, a hardware perspective, but also from a grant funding perspective as well. I'd now like to open up the floor to questions, and between us, we'll do our best to answer any questions that you have. Okay, so we have one question here and a comment from Theodore. So Theodore is a vascular surgeon who made a comment that they have had significant demand for N95 masks and visors, you know, during the last year and a half or so. But he also has a question saying that he's interested in 3D reconstruction of the aorta and its pathological variants, and producing reproducible models for teaching purposes and for developing specific stent models for treatment. I've made benchtop models for teaching, but not been able to make models for teaching skills. Can somebody help? Okay, I will just quickly share with you some information on that. Okay, so while I guess models for pre-surgery planning, for example, aren't a focus of Mark Forge, as we focus on high strength manufacturing and specific properties of materials such as radio transparency, electrostatic discharge, and fire retardants. We do have some applications for, I guess, you know, training and education. And here is an example here of a prostate mold. So basically, what Markforged materials enable is not only high strength, but excellent surface finish. And what that in turn enables is the creation of prostate molds, which are typically for polyurethane. So in this case here, this was for a prostate, and this was also used for for education purposes. As is mentioned here, Mark Ford's 3D printers and materials produce molds with ultra high resolution, which means these particular phantoms in this case preserve fine details and smooth realistic appearances. The nice thing about this is that rather than 3D printing, I guess the object itself when printing